Hello everyone! Today we are going to talk about the information processing model and its application in mathematics education. First, let's see what is information processing model. Within this model, humans are routinely compared to computers. The computer is composed of four parts: input device, storage, CPU, and output device. And its basic procedures of processing information is input, processing, and output. This model considers a person's eyes, ears, nose, and other sensory organs as input device, views the human brain as the CPU and the storage, regards hands, mouth, and so on as the output device. It's important to know that this model doesn't really describe where things happen in the brain, it's more conceptual. According to the theory, the memory store is viewed as three stages including sensory memory, short-term memory, and long-term memory. The first stage is getting the input, which occurs in sensory memory. This is where you first interact with the information in your environment. It's a temporary register of all the information your senses are taking in. We know the basic five senses: sight, hearing, taste, smell, and touch. So just think about all of the information that's coming in through those basic five senses. Sensory memory lasts a different amount of time depending on the modality of the information coming in. Visual information is incredibly vivid, but it only lasts for less than half a second. Auditory information lasts a little bit longer, for about 3 to 4 seconds. The information in sensory memory is so huge that we can't possibly process all of it. If we pay attention to some parts of the information, it will be delivered into the short-term memory to be processed. Otherwise, this information will get lost forever. Short-term memory is also called working memory, and is what we're thinking about right at this moment. This stage works a little bit differently. Your working memory is limited and can hold about 7 plus or minus 2 pieces of information at a time. The information has 3 deducts in short-term memory. First, if we don't think it's important or if something else more important comes and pushes the information come out, the memory will be lost. Usually, the duration of the short-term memory is about 5 to 20 seconds without rehearsal. Second, if we rehearse or repeat the information over and over, it will stay in our working memory for a little bit longer than normal. Third, the information goes into our long-term memory. Moving information into our long-term memory is how learning actually occurs. Long-term memory is the final stage where its capacity and the duration are nearly limitless. In order to transfer the information from short-term memory to long-term memory, what we need to do is encoding the information in a meaningful way through pictures, mnemonics, or labeling, and so on. It's also necessary to organize new information largely by relating it to something already known. We also can bring the information back into short-term memory from long-term memory when needed. There are 2 types of long-term memory. One is declarative knowledge, which is the smallest unit of knowledge that can stand as a separate assertion and deals with factual knowledge. For example, 1 meter equals to 100 centimeters. The other one is procedural knowledge, which is a way of representing condition action rules and deals with knowing how to perform an activity. For example, ride a bicycle. Now, do you have a basic understanding of the information processing model? Next, let's move to the application of the model in classroom.
How to apply the information processing theory in mathematics education. According to the theory, the information obtained by the students from their sensory organs will first reach to their sensory memory, and the information is only kept for a short period of time. If students do not pay attention, they will easily lose this part of information. Therefore, when teaching new knowledge, the form of knowledge presented by teachers must be able to draw attention from students. So how to attract students' attention to the information? Here are some tips. The first one is using different color charts to separate the basic graphics from the complex graphics. which has a strong stimulating effect to students and is easy to attract their attention, so that it can cause their further information processing. The second one is emphasizing important knowledge repeatedly. The third one is symbolic graphic combination, which can make abstract knowledge more concrete. The fourth one is using bold writing. Teachers should speak while writing so that students can receive information from sight and hearing. After attracting students' attention to the knowledge, we need to help them organize knowledge. Because the capacity of short-term memory is limited, new information will replace old information. Therefore, teachers should make connection between new knowledge and previous knowledge and guide students to summarize the rules of learned knowledge and then associatively memorize them according to the rules, so that the amount of information contained in the short-term memory will be significantly increased. There is an example shows how to attract students' attention and help them organize knowledge when teaching. The question is, find the general formula of 1 cubed plus 2 cubed plus 3 cubed plus n cubed such that n is a natural number. First, we can let students assign different values to n, and then consider geometric meaning of the results. Since each result is a perfect square, so that it is not difficult to associate with the area of a square. Second, we can use GeoGebra to show the expressions in the geometric perspective, so that students can easily find the change rule of the length of the square side. Third, encourage students to infer the general formula. Finally, use mathematical induction to prove their inference. Through symbolic graphic combination method, not only can attract students' attention but also make abstract knowledge more concrete. Moreover, summarizing the rules from the application of previous knowledge is also an important way to train students' logic thinking ability.
We can also help students encode the important information from short-term memory to long-term memory by constructing a stable knowledge structure. The research shows that CPFS structure is a good mathematical cognitive structure, which is helpful for the storage and extraction of knowledge. The CPFS structure refers to the structure of the conceptual domain, conceptual system, propositional domain, and propositional system. Among them, the conceptual domain refers to the set of various representations of the same concept. The conceptual system refers to the network formed by the relationship between similar concepts. The propositional domain refers to the set of equivalent propositions of a proposition A. The propositional system refers to the schema of a set of propositional networks with the existence of a relationship. So, we can apply the following methods in mathematics learning and teaching. First, we should enable students to form conceptual domains and conceptual systems. In concept learning, we need to understand concepts from multiple points of view, levels, and backgrounds. For example, we can define the concept of parallelogram in many different ways so as to form conceptual domains. The conceptual system refers to the relationship between the concept and other concepts. For example, the relationship between the concept of parallelogram, the concept of rectangle, and the concept of rhombus, which are shown in the figure. After that, we can form a relatively systematic conceptual system and form a clearly schema for the concept. Second, we should enable students to form propositional domains and propositional systems. As we all know, students need to extract learned knowledge from long-term memory in solving problems so that they can be returned to short-term memory and then be processed. However, because the capacity of long-term memory is very large, it brings trouble to information retrieval. In order to make information quickly retrieved when it is needed, we need to get students to form propositional domains so that they can take shortcuts to retrieve the necessary information directly. For example, there are several ways to prove a triangle is an equilateral triangle. In addition, we should organize related propositions to form propositional system so as to facilitate retrieval. The related propositions will form a schema in long-term memory. When the knowledge in the set is extracted, the related knowledge in the propositional system is activated, so that the knowledge in the own propositional system is activated. In a word, the block and coding of knowledge should be unified. Coding occurs during the transformation of information from short-term memory to long-term memory. The way of coding is related to personal knowledge and experience. It also has a direct connection with the teaching experience of teachers.